Hello everybody and welcome to today's webinar, which is going to be about manual inspections and how you can digitize your manual checklists. Looking at the attendees list for this webinar, I can see that we are mostly existing customers, and I assume that you have some knowledge into WATS. So I'm not going to repeat today the very basics of manual inspections. So if you're totally new to WATS, this might be a little bit hard to follow, but I will try to cover some more use cases and how you can configure your manual inspections and repairs to be able to work in a more lean way. So today's agenda is going to be about creating and maintaining the manual inspections, which is done in the WATS control panel. It's going to be about executing MIs in the operator interface. And I'm going to talk a little bit about manual inspections and repair and how they combine and how you can set it up to be more lean. And then we're going to go through some tips and tricks and things that you might not know about. So this entire session will be a live demo. I will not be presenting any slides, so I will go right ahead and switch to the WATS application. And now we're at the start page, and I will go directly into the operator interface. So for anyone new to WATS, the operator interface is where the technician and operators can perform any manual work and log the result directly into the WATS application. So you can load the unit and see the history and see the state of that unit, and you can perform manual inspections and repairs depending on your needs. So the operator interface, you typically scan or type in a serial number, part number, and so on. So if you have barcodes on your devices, it's really helpful to configure a barcode scanner and allow the operator to scan serial numbers. But in this case, I will just use made-up serial numbers, and I will make up one that is non-existing. So let's just call it T1000, and let's make a part number ABCD. And we can give it a revision as well, and we can give it a batch number. The only two that are required is the serial number and the part number. Revision and batch number is optional. So once I scan this unit, the unit will be loaded into the operator interface. And for these units that did not exist, nothing is of course loaded. So there's nothing in the serial number history. And if I go look at any of the other options, unit verification, it will not be able to give me any unit verification either, because there are no UUT or no UUR reports out. So the first thing I'm going to do here is to just run a manual inspection, as an operator would typically do. And there is one inspection that comes with the WATS trial account. So I'm first going to just run that one. It's called manual inspection example, and I can see that it's version 1. And the process it will be logged to is manual inspection, which is maybe a little bit unnecessary duplicate of that name. So then I choose my inspection and I start it, and that takes me to the first page of the manual inspection. And the first thing we can see here is a subunit grid. So that's an optional thing in the manual inspection. So here I can add any subunits that are inside my module. So let's leave that alone now and scroll a little bit down here. I can also see here that there's a required custom parameter with a drop down. So this is just an example. So ABCD, I choose one of them. I can add a comment that applies for the inspection itself, or I can just start the test. And as you can see in the left-hand side, you have the entire sequence list. So I start the test and I'll be taken through the steps one by one. You can have a PDF showing in the right pane of this view, and that PDF can scroll to whatever page you want or whatever text you want, depending on what step you're at. So this will simply take me through the sequence, and this typically illustrates the type of steps that you will find in a manual inspection. So first there's a message box with some options. I'm allowed to add a comment, add the image, I choose B, and I'm taken to a numeric limit step where I have limits, 2.5, 8.4, let's say 5 and pass it. And you can see here, I'm arriving to some subsequences, so you can add nested sequences inside manual inspections. Take it to a pass-failed step, pass this one, a stream value step. Then I have a wait step that will wait for some seconds. I'm allowed to attach a file, and I can add subunits again. Once the inspection is done, I simply submit it, and the result of the manual inspection is a UUT report. So experiencing a demo syndrome here now. Here we have it. So now it's loaded in the serial number history, and now this unit actually has a report, and we can open the report to review it. So a manual inspection report ends up as a UUT, just like any other test in WATS, and you can of course then analyze it just like any other test as well. So that's a typical MI example, a typical test that you can design inside WATS. So now we have looked at how the operator typically runs these tests. Let's go and look at how you actually create them and maintain them. And that goes on in the production manager. So a good tip for anyone that still doesn't do that, use this search option in the top center of the screen. And I can start typing production manager. And in the production manager, I will be able to find all my manual inspections. There are also other things in this list, software packages, among others. So in this case, we'll just look at manual inspections. So I can actually hide the software, and we'll see here all the inspections defined in the system. So this one was the one we run, and by clicking it, I can load the sequence here and look at the details. So it has a name and a description, and then it has some settings. So it has a global setting. If you turn that global setting on, you will be allowed to use that sequence as a subsequence of another manual inspection. So you can reuse a sequence if you have a small sequence that often is reused across different tests. And then you have some other options related to repair, which we're going to cover a little bit more later. So you can decide when the MI runs and fails if the operator will be taken directly to repair. And then you can choose that it's required to do the repair right away. It can be optional, or it can be turned off, so never. And then you can also choose which repair operation should be triggered. You could choose any and let the operator select one, or you can specify the specific repair you want used in this scenario. And then you have some settings here as well. Display subunits grid. That was the grid we looked at in the first page of the manual inspection, which lets you add child units to the test report in a grid interface. The submit UUT UR on first failed step simply means that once a step fails, the inspection stops, and you have to submit the report as it is. If it's turned off, you can continue the test and do all the other steps, and then submit the failed report in the end. The auto-create new manual inspection on UUT failed is also a lean option, which lets you automatically redo the inspection if it fails, and then you do a repair. So you can kind of do all the 3 steps simultaneously by first doing the inspection, logging that it failed, logging the repair operation, and then redoing the tests to get a passed verdict. And then these are simply logging additional data, so you can log the UUT MISC info from the previous report, and you can include UUR MISC info into the UUT report, and log operator and log step description. So all of these are turned on. So these are the settings, and then we have the sequence designer. So when you are going to design the sequence itself, you will have to use an external tool. So the first time around, you'll have to install it. Next time you will download, and that will download a file. And once you open that file, we'll open this editor where you can see the sequence. So here I have steps in sequence, and I can click this little option button to look at the options for each of the steps. I will not go into the details of these steps. It's pretty simple. You can combine them however you want. Once you have done your changes to the sequence, you simply save and close. And then there's an instruction PDF, so you can upload any number of PDFs to the sequence, and then once they're uploaded in the sequence designer, you can reference these PDFs and show a specific page or search for a specific quote or word. And the last tab, but a very important one, is the relations one. And what this one does, it links the inspections to typically a unit part number or a batch number or a range of serial numbers. It could be a station name and so on. So the point of this one is to allow the operator, when he scans a unit in the operator interface, to only be able to choose the sequences that applies for him in his context. For instance, for the part number he's working on. And in this case, it's used a wildcard. This is just an example. So it's set up like this to apply for any part number. So any part number you scan in the WATS interface, WATS operator interface, will enable this inspection. And then in this relation, I have the test operation. So this is the resulting process that will be used for the UUT report. And it's a little bit confusing that this one says manual inspection as default, because that's maybe not the most useful information about this process. And if you have more than one manual process in your line, you will anyway have to be more specific. So you shouldn't do all your manual inspections and log them as manual inspection. If it's an end-of-line test, you should log it as end-of-line tests. If it's an assembly step, make a process called assembly, and so on. And you can set up more than one relation in this view as well. And once the relation is created, the report will be available on the operator interfaces. And then there is one more part that applies to the manual inspections, and that is the version and release date. So you can see in my list here, I have 2 different colors. I have this orange brownish color, and I have these green ones. You can see the same colors here in release and move to pending. So in my case, I have 2 inspections that are released and available in production. And I have 3 here that I have prepared. They're moved from draft to pending, but they're not released yet. So you can use these steps to develop the next version of your sequences and test them before you release them. And once you release them, it's a one-click release to all users. So the way this works, let's make a new manual inspection. will just leave it like this. And now you can see it's blue, it's in draft, and you can see the version number is 1. If I want to release it, I first have to move it to pending. And once it's in pending, I can no longer do edits, but I can test it. And if it turns out that I want to do more edits, I can move it back to draft. So then I can go move this one back to draft to make additional edits. Then I move it to pending, and I'm happy with the testing, and then I can do a release. And now this one will pop up in the operator interface. If I want to make additional changes, I can now no longer move this one back to draft. So what I'll have to do is to make a copy, and this one will automatically get the next revision number. And I can now do the edits. I can move it to pending, and I can release, and that will overwrite that, or I will release the new version, and it will revoke the first one. So this way you can stay in control of what is actually used in your production environment. So let's go back to the operator interface. And load our units, and I will click the MI icon, and here we will have the list of available MIs. So as you could recall, there was one manual inspection example, and then there was another one, manual inspection override, which was another example. And this one exists in 3 different processes, and I can explain the use case here. Let me just keep the production manager open as well. So we see a typical scenario in WATS is that a good unit may fail for some reason at some step, and depending on how the flow of goods are in your production, this unit can be taken out of the line, and it can be manually inspected or manually repaired or reworked or whatever. And in some cases, it's not practical to move it back into the line at the same point. And maybe it's also possible to do just the same verification as the ATE did manually. So you kind of want to do this same checkup and pass the unit through its process. And this is what the manual test result override inspection is an example of. So here you have a customer tests in an ATE, for instance, in an ICT test, and then it fails. And sometimes the failure is not the unit. It could be a cable, it could be a fixture, it could be software or test software or test equipment problems. And once you have done the root cause analysis and concluded and tested the unit manually, then you can run such an inspection to simply pass the unit in a specific process. This is, of course, obviously something that we is a little bit on the side, but it's always good to have the full story. So if you have the failed test from the ATE tester, and then you have a repair report that explains that no failure was found, and a comment on what was the cause of the failure. And then you have a retest, either by running it through the ICT tester again, or by running a manual override and accepting the units. So in the relations for this one, you can see that I have selected several processes. So that will enable me to run that test and override result in the end of line, or in the functional, or in the programming stage. Great. Back to the operator interface, I'll go into the operator interface configuration, advanced configuration, and this is where the setting is set for which release status is used. So the default is of course released, so released sequences will be available in the operator interface. But in this case, I will switch it to pending, and then I will load my unit again. I'm clicking this now, I will get a different result. So now I have the orange ones from the production manager, which are related to repair. And I will showcase 3 simple manual inspections, one without repair, one with repair, and one with repair and retest. So these are set up by the options in the manual inspections. So running the first one is a simple inspection that does not allow the operator to do any repair. So the operator inspects, and in this case, the measurement fails, and the operator is simply only allowed to submit the report as a failed unit. And in this case, with this setup, the unit will typically go to another cell where the rework will be done. So then when it arrives in the rework, someone else will do a repair, link it to the failure from the manual inspection, and log the failure and log the repair report. So now I have the failed inspection, I have the repair, and then typically it goes back into some kind of test, and this runs the same test over again, and this time I pass it. Just have to be patient. It's incredibly tempting to just click reload, but there we have it. So now I have the full story. I have the failure, I have the repair, and the manual inspection. For some reason, the sorting was wrong here. And then, even though you will still have a hurt in the first pass yield for this unit, it will, in terms of, for instance, a certificate, it will make more sense for the customer to see that story. Let's do it again, and in this time I want to do it for, let's make a new unit. Go to the MI, and then this time I will select MI repair and continue. So what this does, same thing, I start the test, then I fail it, and immediately the repair interface is shown in the manual inspection. So then I can select my repair action, I can confirm the repair, and I can, in this case, continue the test and submit. So now this one process creates the inspection and the repair action. And you would have to do a new manual inspection to pass it by running the test again. And then the last option will unfortunately look more or less the same in this example, because when preparing for this, I discovered that we have introduced a little bug, but I will do it anyway. So the next thing I will do now is run an MI that does the repair, that fails the inspection, does the repair and starts a new MI for the test in the same go. So the first part is the same. I start the test, I fail it, I'm taken to repair, I do the repair, and I submit, and here is a little bug. So now the new MI, the same inspection is supposed to just restart. It will when I click this one, then it will be taken into the correct. So we will report this bug and have it fixed as soon as possible. So that allows a user to with relatively few clicks be able to fill in the missing reports from between the automated tests. Okay, I guess we have a couple of minutes left if there are any questions. Let's see. Yeah, there's a question related to a serial number problem. So let's say that you do not use barcodes and I type in, for some reason, something wrong. And then, unfortunately, if you don't notice and start doing work on this, reports will be created using this serial number. And there's no good way of stopping this using WATS without what we call the production module. But what you can do as an administrator or as a manager of WATS is that you can open those reports inside the UUT report. You can click Edit Header, and then you can do your modifications here. This is something that we advise that you only do for typically these kind of things. So you're fixing something that was logged incorrectly, not fixing the verdict or result of the report, for instance. Yes, it's possible to add the serial number with a barcode reader, and I can show that just quickly. So what you'll have to do is you will need a barcode scanner that has a prefix in the beginning and a suffix in the end. So it sends a key combination first, and then it sends the barcode, and then it sends a new key combination in the end to sign that this is the start and the end. And once you have that, in 9 out of 10 cases, more as well, you can simply click this configure scanning, and then you can use your barcode scanner to scan this. And then the configuration will be finished. The problem is also that you might need to configure the barcode format. So the default of the barcode format in WATS, let's say, there's a barcode identifiers part of the API. And if I use this one, I will get the ones that are configured on the system. So this one says, and this is a little bit hard to read if you're not familiar with regular expressions, but it simply says that it expects this format. First, the serial number, part number, revision, batch number, and process, separated by slashes. You can alter this pattern to accommodate for any combination or format that you have. And you can also use more than one, so you can have additional ones, and then the order will be determined which is processed first. And then I got a question about subunits, which is a big and troublesome topic. So subunits is related to box build, and we briefly saw a subunit grid, and there is also in the manual inspections a add subunit step. And subunits in WATS exists in 2 domains. So for most WATS users, use only the TDM database, so which handles the test data management, and everything is based on UUT reports. And in that case, there is really no check related to subunits. Subunits are just another property on the report, and it's a garbage in, garbage out situation where you can essentially put anything in. In the manual inspections, you can make some configurations. So when you do the add subunit step, you can specify. Yeah, I don't think we'll have time to go in there, but you can specify on that subunit step which part number and revisions goes in there. And then there is another option if box building is a big thing and putting the correct part in the correct module is important, and validation is really important. Then there is something called WATS production. I will not be able to go into that now, but essentially it adds a current state for any unit in the database, and it's mainly made for a way to integrate with, so that you can do synchronous communication to WATS and ask what's the status of this unit, which subunits are inside of it. And once you use that, then you have some more options in terms of defining which subunits goes in where and so on. So if subunits is a big thing and it's a challenge for you, you can reach out to the support or to me, and we can discuss what your challenges are and how we best can solve them. Yeah, this is a good one. So what if you have a 20 units in a batch that are sent to repair, and you know that the same thing is the problem with all of them, and it's not very lean to scan them one by one and do the same operations 20 times. We get this question a lot today. That's the only option. We are looking into at least improvements to how you can do batch edits, how you can scan 10 units and edit them in a more efficient and more lean way than scanning them one by one. And then there is also an option when it comes to the operator interface. Also keep in mind that we develop this for all our customers, which range from defense to medical to making small electrical devices and space. So this will never be lean enough for all of you in all situations. But it's a pretty small thing to make an integration with, if you have an existing system where you do manual work, or to simply mock up a web interface that is more custom and more suited for your lean workflow. And then that system, that web page, can simply create a UUT report or a UUR report for repairs and send them to WATS. And you will have the same result, but with a custom interface. Perfect. Then I think our time is up. So I'll just thank you for listening and wish you a nice day. Bye-bye.